Okay, so this is the key to section 4.4 part 3, and this is where we're solving log equations. And in each of these cases, for example, number 1, you're going to change these to an exponential equation, and so that's how you're going to solve for the variable x. You're going to rewrite all of these using properties, and then in the end you're going to change it to an exponential equation, and you'll be able to solve for the variable x. Okay, so for example, over here you have the log of 2x minus 1 base 2 is equal to 3. So remember, one of our properties said this, where you had, let's say, y equals log base b of x. Okay, and so to solve for the variable x, you would change it to an exponential. So you would say b to the y, so the base is b, so an exponential. This is equivalent to saying this base of the log is the same as the base of the exponential, so b to the y equal x. So you're going to change the logs to this. Now, when using this definition right here, you have to have the log by itself, like this, with a coefficient of 1. So this must be a 1. Once you have the log by itself, coefficient of 1, then you can change this to an exponential. So something like this. So this log's by itself. The coefficient of the logarithm is 1. So now I can change it to an exponential. So you take the base, b, which is 2, and you raise it to the third power, and that equals the argument, so 2x minus 1. And so 2 to the third power is 8, and 8 equals 2x minus 1. And notice all you're doing now is just solving this linear equation, so you're going to add 1 to both sides. So 8 plus 1 is 9, equal 2x, and then divide by 2, and you get x to be 9/2. Okay? Now, here's the thing, though. And so in the lesson, you learned that you can only take the log of a positive number. So if you have this expression, log of m base b, m must be positive. So m has to be a positive number. So you must check these proposed solutions. All you have to do, really, is just to make sure that the argument is positive. So when I substitute 9/2 back into 2x, 2x times 9/2 is 9, 9 minus 1 is 8. And it kind of makes sense because 2 to the third power is 8. So this had to be 8. All right, so this is good, so we're going to say 9/2. Okay, over here, now this is a little bit different. So notice the log's not by itself. In fact, there are two log expressions. But remember, we know a property that said that the product rule that said that the log base b of m plus the log base b of n equals the log base b of the product m times n. Okay, so that's what we're going to use here. So you got to condense this. You have to condense this to a single logarithm. So you have to have a single logarithm just like we had here. So when you rewrite this, notice the base is the same, so I can rewrite this as a product, as a single logarithm. So I'm going to say the log base 9 of x times x minus 8, just like this. So notice I put this in brackets because I'm taking the log of this whole thing. So this is what I'm taking the log of. And then that's going to equal 1. So now that looks like this. This right here looks like this. So you have to, first of all, condense this. And also notice that the coefficient of the log here is 1. So I change the exponential. So I say the base is 9 raised to the first power equals x times x minus 8. So that's where I'm at. Okay, so notice this time, though, that see how this was linear? This here is quadratic. So I'm going to be solving a quadratic equation. So if I distribute this, I get 9 equals x squared. X times x is x squared, and x times a negative 8 is a negative 8x. Now, the ones here will be factorable. So if you don't remember how to factor some of these, then use a quadratic formula. But it's got to be in standard form. So in other words, you have to have 0 on the other side. So I get x squared minus 8x minus 9 equals 0. All right? And then if I factor this, I'm going to go ahead and factor it here. X squared minus 8x minus 9 equals 0. So if I factor this, now if you use quadratic formula, it's the same thing. So quadratic formula, a would be 1, b would be negative 8, and c would be negative 9. But if you factor this, you should get x minus 9 times x plus 1. And always check yourself using a FOIL. X times x is x squared. The outer is a positive x. The inner is a negative 9x. When I add a positive x and a negative 9x, I get a negative 8x. And the negative 9 times a positive 1 is a negative 9. And then I use a zero factor property. So I got to say each of those factors equal to 0. So I get x minus 9 equals 0, x plus 1 equals 0. So I get x to be 9, and x to be negative 1. Now those are your proposed solutions. Okay? So you got to make sure that, remember, you got to only take the log of positive numbers. So you got to make sure that when you plug those numbers back into the argument, that the argument is positive. So now let's try 9. So when I plug 9 here, I'm taking the log of 9. That's possible. 9 is positive. The argument is positive. Here, 9 minus 8 still a positive 1. So 9 is going to be a solution. Here, negative 1. Now again, that's assuming that I did all this work correctly. All right. So I'm really saying, and you can check this. Look. The log of 9 base 9. That's 1. The log of 1 base 9 is 0. 1 plus 0 is 1. Let me show you what I just did, if you want to check. Watch. Okay, look. So you want to check 9. Look how simple this is. Check x equal 9. Now, really, all you have to do is just check the argument. All right, so the argument here is positive. We're going to plug in 9. The argument here, 9 minus 8 is 1, so that's positive. All right, but if you want to check to make sure that this was actually a solution, see here, I'm just checking to make the arguments positive. This could still be wrong, but let's check and see if it's correct, though. So you're going to say the log of 9 base 9 plus the log of 9 minus 8, and I want to see if that's equal to 1, right? Okay, so the log of 9 base 9 is 1. 9 to what power is 9? 1. Over here, that's the log of 1 base 9. Well, think about this. Log base 9 of 1. What does that equal? Well, 9 to what power equals 1? Well, 9 to the 0 power is 1, so that's 0. And 1 plus 0 is 1. Okay? So it checks out. So I actually did the work correctly, and this is correct. Okay, but now when I plug in negative 1, notice what happens. Right away, I'm taking the log of a negative 1. Well, that's not possible. You can't take the log of a negative number. All right, you may say, well, why not? Well, let's think about this. Let's go here. Let's think about the log of negative 1 base 9 and kind of see what that exponent equals. 9 to what power is negative 1? Okay, that's a question. Well, a positive number raised to any power is never going to be negative. This is never negative. So that's why you can't take the log of a negative number. There's no exponent that you can use with that base that's ever going to be negative. So this proposed solution is extraneous. All right, so remember that extraneous means that it's a false solution, but basically it's a solution to this quadratic, but it's not a solution to the original equation. Okay, so this is the only solution. All right, so just remember though that we have to use this property. So the log of m base b plus the log of n base b is as a single logarithm. It's just the log of the product of the two arguments. Over here we have a division. So what we have to use there is the quotient property. So we have the log, remember the log base b of m minus the log base b of n equals the log base b of the quotient, m divided by n. So here I'm going to condense. Now remember that you have to have the coefficient of 1s before you can condense. So, and I do. So I have the log. Now see there's no base here. You see there's a base here of 9. Here there's no base. Remember you're dealing with a common logarithm. That's base 10. So that's going to be 5x minus 1 over x minus 2 equal 2. All right, so now I wrote it as a single logarithm, so now I'm going to change it to exponential. Base is 10, keep that in mind. So I'm going to say 10 squared equals 5x minus 1 over x minus 2. Now 10 squared, remember, is 100. So I'm going to write this as 100 over 1 equals 5x minus 1 over x minus 2. Now this is a proportion. So a few semesters ago, you learned that when you have a fraction equal to a fraction, you can solve this by cross multiplying. All right, so you would get 100 times x minus 2, so you cross multiply, equals 1 times 5x minus 1, which is just 5x minus 1. And so when you distribute, you get 100x minus 200 equals 5x minus 1. All right, and so when you solve, I'm going to go ahead and write it here. So when you, remember, you cross multiply. That's only true if it's a proportion, one fraction equal one fraction. And so let me go ahead and rewrite this. Okay, so then that's minus 1. So then we subtract 5x from both sides. This is linear. So I get 95x minus 200 equals a negative 1. Then you can add 200 to both sides. Combine like terms, I get 95x equals 199. And divide both sides by 95. I get x is 199 divided by 95. Okay? All right. So you got to check your proposed solution. So let's just go back to, let me make sure that I said 10 squared, so that's 100. Okay, so just verifying this is correct. All right, so 199 divided by 95, let's see what that is as a decimal. Maybe we can use this decimal. So it's a decimal that doesn't terminate. Okay, so let's just go ahead and use the whole thing. So we're going to say 5 times, so 5 times, right here, 5 times x, which is 199 divided by 95, so times 199 divided by 95, minus 1, just like this, minus 1, equal. Is that positive? Yes, that's positive. Now let's check the other one. We got to check both arguments. So 199, see that's x, so x is this, 199 divided by 95, minus 2, is that still positive? Yes. So 199 divided by 95 works. Okay, leave us a fraction. All right, now what I wanted to mention here was that some of you probably forgot all about cross multiplying. All right, well that's no big deal. You can do this if you want to think of it this way that I'm about to show you. So we have 100 over 1 equals 5x minus 1 over x minus 2. So remember though, this is a rational equation. So even though we said it's a proportion, it's still also a rational equation. You have fractions involved. And so the LCD here is x minus 2. And so what I can do is multiply both sides by x minus 2. So I'm going to say x minus 2 times 100 equals, and then this fraction right here, times x minus 2. So all I did was I took this side, multiplied by x minus 2, took this side, multiplied by x minus 2. See it? So I multiply both sides by x minus 2. These x minus 2's divide out, and so you get 100 times x minus 2 equals 5x minus 1. And notice, guys, this is what you had here. See right here? So this is this. So if you didn't remember anything about this being a proportion and cross multiplying, then you could use what you've learned in this course in terms of, and the previous course, in terms of solving rational equations. You multiply both sides by the LCD. Okay, and then you just continue. All right? Okay. So then we go to number 4 rather. And number 4 we have a sum again. So we're going to condense this. So this will be the log base 2 of x times x minus 2 equal 3. All right. And so now I have a single logarithm. So you remember you had to condense first. I have a condensed to one single logarithm. So I have a single logarithm. So now I can use the exponential. I can change this to an exponential. So that's 2 cubed equals x times x minus 2. And 2 cubed is 8. So I get 8 equals, and then distributing this, notice this is going to be quadratic. I get x squared minus 2x. And then changing this to standard form, bring the 8 over so you can have 0 on the other side. I get x squared minus 2x, and then 8 becomes negative 8 equals 0. And then factoring, I get x times x. As I want the last to be negative 8, and then the middle to be negative 2. So the only way they can work is if this is x minus 4 times x plus 2. And let's check. The outer is the 2x, the inner is a negative 4x. When I add them up, I get a negative 2x. And the negative 4 times a positive 2 is a negative 8. And then using a zero factor property, I said each one equal to 0, just like this. And these are linear. So I went from a log equation to a quadratic equation to 2 linear equations. So x is 4, x is negative 2. All right. Now you got to check these, so don't automatically say those are your solutions. And assuming that all this worked correctly, all you have to do is, assuming you did all this work correctly now, all you have to do is just put this back into the argument. So when I substitute 4 into here, I am taking the log of 4, so that's positive. 4 minus 2 is 2, that's positive, so I'm good. So 4 is going to be a solution. When I plug in negative 2, though, right away, I'm taking the log of x, and we're saying my proposed is negative 2. I cannot take the log of negative 2. I can't, the argument must be positive. So I can't use this one. This is extraneous right here. All right, so meaning that it satisfies this quadratic, but it doesn't satisfy the original. Okay, now, just a reminder, see how I factor? Some of you may not remember how to factor. Well, hopefully you do. You've had several courses already where factoring was involved. So you can use quadratic form if you want to. So you could use, for this quadratic equation, you can use the quadratic formula. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And a here is a coefficient of x squared, that's 1. B is a coefficient of x, that's negative 2. And c is your constant, that's negative 8. And just a matter of you plugging these values back into the formula. So this says the opposite of b. Well, b is negative 2. The opposite of negative 2 is 2. Plus or minus the square root of b, which is negative 2. I've got to square that though. Minus 4 times a. A is 1. Times c, which is negative 8. All of that is being divided by 2 times a, and a is 1. So you get 2 plus or minus the square root of. Negative 2 times itself is 4. A negative times a positive times a negative is a positive. 4 times 1 times 8 is 32. All over 2. So you get 2 plus or minus the square root of 36. 4 plus 32 is 36 over 2. 36 is a perfect square, so the square root of 36 is 6. So I get 2 plus or minus 6 over 2. And then, remember, there's no square root, so this is going to be a rational solution. So you say 2 plus 6 divided by 2, and then 2 minus 6 divided by 2. 2 plus 6 is 8. 8 divided by 2 is 4. And then 2 minus 6 is negative 4. Negative 4 divided by 2 is a negative 2. So, and notice I got 4 negative 2, which is what I got here. Okay, when I factored 4 negative 2. Okay, number 5. Again, this is an addition, so you can change the multiplication. Bases are the same. So you say the log of base 4 of x times x minus 6 equals 2. And now I change it, since I have a single logarithm, I change it to an exponential. So 4 squared equals x times x minus 6. 4 squared is 16, so I get 16 equals x times x minus 6. And notice this is quadratic, so I'm going to distribute this. So you get 16 equals x squared minus 6x. Now remember, I'm going to factor this. These are going to be factorable. So, and even if you was using the quadratic formula, you got to have 0 on the other side, so you got to write this in standard form. So x squared minus 6x, and 16 becomes minus 16 when I subtract 16 from both sides. This is what I'm saying right here, equals 0. And so factoring it, you're going to get x minus 8 times x plus 2 equals 0. So that's how you're going to factor that. And it works out because the outer is 2x, the inner is a negative 8x, and when you add them up, you get a negative 6x. And the last, a negative 8 times a positive 2 is a negative 16. Now remember, you can use the zero factor property next. You can set each one equal to 0. And so you get x to be 8 and x to be negative 2. All right. Now, you got to check your solutions. All you got to do is just check to make sure that when you substitute these back into the argument, it's positive. Again, I'm assuming that all this work is correct. All right. So you could have messed up and say it's 7, and then 7 would still make it positive, but really 7 is not a solution because you messed up. All right. But really, it's all you're checking is assuming this is correct. Let's make sure that the argument is still positive. So in 8, when I substitute 8, I can take the log of 8, so 8 is positive. 8 minus 6 is still positive, that's 2, so we're good. But when I substitute negative 2 right away, when I substitute this argument, I can't take the log of negative 2, so this is extraneous. Right. Now be careful, don't just assume that it just occurred in these problems here the way I've made them up, but when you're solving a log equation, it is possible that x, your solution, can be negative. That negative 2 can still make the argument positive. Okay? We just didn't have that situation here, and we won't. All right, so don't automatically assume because it's negative it's going to be extraneous. All right, so solution is 8. Now let's do this one. So this is subtraction, so we're going to change this to, we're going to use the quotient rule. So I have the log base 3 of x plus 4 divided by x minus 4 equal 1. So I wrote as a single logarithm, so now you're going to change it to exponential. So 3 to the first power, which is 3, equal the argument, which is this. So I get 3 over 1 equals x plus 4 over x minus 4. And notice it's a proportion, so let's just cross multiply. So you get 3 times x minus 4 equal 1 times x plus 4. Now, if you want to multiply both sides by the LCD, you're going to get this. You're going to multiply this by x minus 4. The x minus 4's divide out. Notice you get this. You multiply this by x minus 4, and you get 3 times x minus 4, which is this. Okay? All right. Now, distributing, I get 3x minus 12 equals x plus 4. And this, now notice this is linear, so subtracting x from both sides, I'm going to do that here. I'm going to get 2x minus 12 equal 4. Adding 12 to both sides, I get 2x equal 16, and so x would be 8. And all you got to do is just, assuming this is correct, and it is correct. So assuming this is correct, though, just make sure that it still makes the argument positive. 8 plus 4 is 12, we're good, that's positive. 8 minus 4 is 4, we're good. All right, so that's your solution. Okay, so that's going to take care of this worksheet. So this was worksheet 4.4, part 3.